Hey guys, welcome back to chapter 17. We're going to run through one more example of average reaction rates. And then at the end of this video, I'm going to kind of lead you into or foreshadow you into the next topic. So here's another example. Consider the balanced chemical reaction. So step one, I want you guys to write the average rate of the reaction for this equation with respect to I. So write the rate equals and then use I. So rate equals, we are going to have the change in time on the bottom. We're going to have change in concentration of iodine on the top. Iodine, is it a reactant or a product? So it's asking us for this one, so it's a reactant, so we'll have to put that negative there. And then also our iodine has a coefficient, so we don't want the rate per 3 moles, we want the rate for 1 mole. So we're going to divide this by 3 or multiply it by 1 over 3. So that's our equation for the average rate with respect to I. Second half of this problem, in the first 10 seconds of the reaction, the concentration of I drops from 1 to 0.868. Calculate the rate of this reaction. I'm going to go ahead and pause the video, see how deep you can get into it, and then I'll catch up to you. All right, so we're going to start with our equation. Rate equals -1 over 3. Change in concentration of iodine. Change in time. So I'm going to rewrite this stuff in the beginning, and then I'm going to be a little bit more explicit about the second half of this. So change in concentration of iodine is final minus initial. So the concentration of iodine drops from 1 to 0.868. So the final concentration, what it ends up at, is the 0.868. Minus the initial concentration, so drops from, that's how I know that's the original. So 1.0 molar. On the bottom, we're going to do the time. So this says first 10 seconds. So the time final, at the end of this interval is 10 seconds. And then it started at 0. So that's how we would denote the first 10 seconds. So again, I'm going to transfer this 1 over 3, and then I'm going to clean up this equation a little bit. So on the bottom, 10 minus 0 is 10. On the top, we're going to have 0.868 minus 1. So we get negative 0.132. And then clean it up one more time. I'm going to divide these two numbers. So negative 132 divided by 10. And we get negative 0.0132. I'll come back to units. We'll circle back. Now I'm going to multiply these two numbers together. So negative 1 over 3 times negative 0.0132. And I get a value, so I'm going to bring it down here. Those negatives, so negative times a negative, those cancel. The number that spits out on my calculator is 0.0044. Let's circle back around to the units. So units are molarity per seconds again. I do want to share with you a way that the textbook often depicts these units. It doesn't really tell you why. So molarity over seconds, 100% correct. Often they will write it like this. So molarity and seconds on the same line. And then they'll put the exponent -1. So this -1 means the same thing as it's on the bottom of a fraction. So if you see these negative exponents on the units, that's what they're telling you. And this is something you will see quite often in this chapter, so I just want to make you aware of it and ready for it. But the answer to this question is rate equals 0.0044. Molarity over seconds, or molarity seconds to the -1. Same thing. Okay. All right, so I want to just kind of summarize what we've been talking about, and then show you how that's going to be different from what we're moving forward into. So what we've talked about so far is the average reaction rate, okay? If I think about average with something that we're familiar with, let's think about how traveling to Raleigh, right? So I may say the average time that it took me to get to Raleigh was an hour and a half, we'll say. So to get to Raleigh in an hour and a half, my speed was on average like 60 miles per hour. Okay? So the average rate of my travels was 60 miles per hour. What we're going to be talking about in the future is instantaneous rate. So during that trip to Raleigh, there may have been a time when I was leaving Wilmington and I was driving 40 miles an hour. There could have been a time that I was on 40 and I was driving 75 miles an hour. And then I get into Raleigh and maybe my speed came down to like 65 miles an hour, okay? So that instantaneous, what speed was I going at each moment? Like, boom, I'm gonna radar gun you. That's instantaneous rate. That's what we're gonna talk about in the future. Average rate was over that long distance, over a big time period. How fast was I going on average? Okay, so average rate, big distance. Instantaneous rate is that cop sitting on 40 going, bam, you're going 75 miles an hour. That's instantaneous rate. And we will have a rate law for that. We'll have a rate equation for that. And that's to come. Don't sleep on average reaction rate. So this is all that we talk about them. The rest of the videos, the rest of the unit is going to be this instantaneous rate. But you will see average rate questions on your tests. So make sure you don't sleep on that. Make sure you come back to study it at a later date as well. I hope you guys found this helpful.